Hello, you guys. It is Thursday. It is the day after we just found out we do not have to go back to school for the rest of the year. Some of you may be happy about that. I am not. I really enjoyed seeing you guys every day, and it breaks my heart that we can't be together. So I'm just going to start with that, because if I talk much more about it, I might have a little cry, and I feel like I've already done that enough. But anyways, I love you guys. I miss you. And yeah. All right, so we're going to keep on keeping on. And I'm trying to keep these lessons pretty short and simple, just because I'm not trying to overwhelm you with work, but I do want us to kind of refresh our memory on the old stuff. After spring break, we're going to go on to the new stuff, okay? And yay, spring break is 2 days away, so we're almost there. Okay, I'm going to go over the homework from yesterday. I had 2 people submit answers, so, or 3 people, I think. They did pretty well, and I'll try to show you some things where there may have been a few issues and whatnot, okay? So, I'm just going to check that the microphone is working on this thing, because I just recorded this video once and it wasn't working. Okay, so let's get started. So for this problem, we're trying to find cosecant. So cosecant is the reciprocal of sine. Sine is O over H, so that means this time we're going to have H over O. All right, so do we know the H? The answer to that is yes, so we could go ahead and fill that in. But this is the A, and we don't need the A, so we need to find the O side, and we're going to do that with Pythagorean theorem. So a squared plus 4 squared equals 7 squared. So we get that, and then we subtract our 16. So a squared should equal 33. And then take the square root. Now you should ask yourself, does this break down? The answer is no. There's no perfect square that goes into that. You can do 3 times 11, but neither of those are perfect squares. So we're going to leave it like that. Now we know our O side, so we can write it in here. And then you just need to ask yourself, does that look right? And the answer is no, it does not. We need 2 times by the quote-unquote problem child, like I've talked about before. And so our final answer should be 7 root 33 over 33. Okay? All right, for the next one, we had to draw a picture. I went ahead and drew it just to save myself a little bit of time. So let's identify the 2 sides that we have. We have secant, and secant is the reciprocal of cosine. So we have the hypotenuse and the adjacent. Okay, so I'm going to put the hypotenuse here, and I'm going to put the adjacent here. And so I'm asking you to find cotangent. So cotangent is A over O. I know the A side, and now I need to find the O side. Okay, so same exact thing as before. So we're going to do A squared plus 11 squared equals 12 squared. So A squared, plus 121 equals 144. And A squared should equal 23. It also does not simplify. Okay, so that's our O side. So now we're going to do root 23. And then I hope, again, you see, do not leave it like that. All right, so our final answer should be 11 root 23 over 23. Okay. And then the last one is cotan. Now, it says 7. So the first thing I hope you guys remember to do is put a 1 under it, and now we can identify the sides. So cotan is the reciprocal of tan. So it's A over O. So 7 is our A, and 1 is our O. And then we're going to do Pythagorean theorem. But this time, we don't have to subtract. We're actually going to add, because we have both of the legs. So our c squared is 50, and our c is square root 50. Now, here's where some of y'all, well, I only had a few people respond, but a couple of issues here is simplifying the 50. So remember that list of numbers that we would write on the board when we did this? So it's the perfect squares. 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 16, 25, 36. Sorry, I just had a brain lapse. All right, there are more, but I'm just going to stop there. So which of these perfect squares goes into 50? And the answer is 25. Okay, so root 50 breaks into root 25 times root 2. And then the square root of 25 is 5. And the root 2 does not have a perfect square, so it stays. So I do not want you to leave it root 50. I want you to leave it 5 root 2, please. Okay, and so now we can do sine. Sine is opposite over hypotenuse. So that's 1 over 5 root 2. And then we're going to times by the problem child, which is just the root 2. The 5 is totally fine being there. And so your final answer is root 2 over 5 times 2. So root 2 over 10. Okay. All right, now I'm going to review. So go back, you guys. I'm sorry, I was moving on very quickly. If you need to kind of rewind or whatever, feel free to do so. That's just basically writing fractions, okay, the ratios of each of the trig functions. Now we're going to use that concept to help us actually find sides and angles. This is actually like a 10th grade geometry standard, but it's very important, so I felt like it was something we should probably review. Okay, so we have two different types of problems. One set of problems is you're going to be looking for a side. That is like problems 1 and 2. Okay, we're looking for a side, we're looking for a side. And in problems 3 and 4, we're looking for an angle and an angle. Okay, so the sides, in my opinion, are a little bit harder than the angles because you have to think about like multiplying or dividing. But they all use the same principle, and it's still SohCahToa. Okay, so I'm going to write that down here again. All right. And so the way that we work these is we're going to identify the angle, and then we're going to label the sides according to that angle. So across from 20 is 12, that's your O, and then beside it is your adjacent. So you're going to ask yourself which trig function uses O and A. And so it is tangent, because that uses the O and the A. So we write tangent and then the angle, 20 degrees, equals O, the O side, over the A side. And then you just need to ask yourself, is this multiplying or dividing? So essentially what can happen here is these two can switch places, so this becomes a division problem. Okay, so I am going to show you how to type this in the calculator in my screen in just a second. So what we're going to type in is we're going to type in 12 divided by tangent 20, okay? And we're going to round to nearest tenth. So I am going to go to Desmos. Let me go back to show you what it looks like. Okay, this is what it looks like when you first get here. And so if you just go and click scientific there in the middle, it'll bring up a calculator, okay, which is super duper nice. And so I'm just going to keep referencing this as we go through these problems. So we're going to type in 12 divided by tangent 20. So 12 divided by, and then tan's over here on the left, 20. Enter. 32.96. Oops, wrong. 32.96. Okay, so what does the 6 tell the 9 to do? It tells it to bump up. So that means X is going to be approximately 33 units. We don't know what the unit is. It might be inches, it might be feet, or whatever. Okay? All right, let's do the next one. So we're going to identify the angle, and across from it is the O, and then across from the right angle is the hypotenuse. So we're going to do sine of 18 degrees equals, oh, I just did that very quickly, but does everybody understand we're doing sine because of the O and the H, okay? Sine of 18 degrees equals our O over our H, okay? And so now we're going to do, in the calculator, you have to ask yourself, is this multiplying or dividing? Well, this is a multiplying problem, so we're going to do 19 times sine 18 degrees, okay? So X is approximately. All right, so let's go to our calculator and we're going to type it in. 19 times sine of 18. And the answer is 5.87. Okay, and so the 7 is going to bump the 8 up. So x is approximately 5.9 units. So both of those problems, 1 and 2, started the same way, but you're going to work them based on multiplying or dividing. So let's kind of write a little note to ourselves. If x is in the numerator, so like x over 12, you are going to multiply. That's like number 2. If x is in the denominator, we are going to divide. Okay? So that's like number 1. And I think most of y'all remember writing this down. Y'all would write these little notes to yourselves on like quizzes and stuff. So I think that's helpful. Okay? All right, let's finish these last 2 problems. So now the last 2 problems are worked a little differently because I'm going to ask you to find an angle. I think they're a little easier. All right, so according to this angle, this side is the A and this side is the H. So we're going to use cosine. Now, the reason this one is a little easier is because you don't have to worry about multiplying or dividing. You just have to remember how to get x by itself. The way you do that is the inverse. And this is what we're going to type in. Okay? So we're going to do second cosine, if you have your own calculator, 4 divided by 11. All right, and I'm going to do it in the Desmos calculator. I'm going to clear all. Okay, so to get the second cosine, change from main over here on the left to function, and then it should come up. So second cosine, and then you got to go back to main and then do 4 divided by 11. Okay, and then hit enter, and you should get 68.67 degrees, which is approximately, if we're rounding to the tenths, that would be 68.7 degrees, because the 7 is going to tell the 6 to go up. All right, and then lastly, here is our angle. This is the O and this is the A. So which one uses O and A? That is tangent. So we're going to do tangent of x equals 14 over 13. So second tan, and then 14 divided by 13. This is what we're typing in, and then I'll show you in here. So I'm going to clear. So I'm going to go second tan, and then I'm going to go 14 divided by 13. Okay? And you can see the answer is, you don't really have to close the parentheses. I'm just a little OCD, so I wanted to. 47.12. And so the 2 is going to tell the 1 to stay. So it'll be 47.1 degrees. All right. So we had 2 where we were finding sides, 2 where we were finding angles. Remember, angles need to have a degree symbol, so don't forget that. And then you need to remember when to multiply, when to divide, and then basically it's just how to type it into the calculator, okay? So you have 4 problems to do here. I would like for you to try your best to use the problems that I just did to help you, and submit those to me through Remind or my email. Awesome. Miss you guys.